Okay, so yeah, so my screen is visible, right? Hello, my screen is visible.
Yes, sir.
Okay, so
Yes, sir.
okay, so yeah, so I guess you know the process. So let me repeat the thing. So you open join pd.com, and then you give that code, whatever this code is written here, njkkqq. Then we'll start like interact.
Sir,
Yes.
so when will be the mock test?
Mock probably will release maybe tomorrow or maybe day after tomorrow. So there is no like fixed time for mock. So we'll just release it as a practice thing. So you can submit whenever you are like ready to solve all the questions. Like after that you can submit it. So there is no, as far as I know, there is no fixed timing for mock. Okay.
And it will be on dashboard, right?
Yeah. We'll send you a mail. Okay.
Sir, I'm audible.
Yes.
Yeah, actually, already week 5 content was released, right? Like post once qualified, whether we receive any qualified, and then only we have to continue that, or how
Sorry.
it's like. Week 5 content already released. Post qualifier only we can continue, or whether.
No, it's up to you. Like if you are like, there is no rule like you have to see it before.
No, like we have completed the qualifier coming Sunday, right? Let's say we are not, we have to submit the assignment by next Wednesday, right?
Yeah, then yeah, that is what you have to do. Like you have to submit the assignment, like whatever is the deadline, you have to submit the assignment before that deadline. Okay. It's up to you when you want to start doing all these things.
Okay.
But you have to complete it.
The deadline.
Yeah.
Like sir, I am in my class 12th right now, so I have will continue my course after completion of my class.
Okay,
12th, right?
just a minute. So this is maths 1 session or maths 2 session?
Maths 1.
Maths 1. Okay, so someone actually asked me something. Okay, Sri Devi CR. So like basically you are asking question from maths 2. Okay, so I guess you have joined in maths 1 session. Okay, so basis linear dependent. Yeah, so please go and join in maths 2 session. Okay, yeah, please.
Also, sir, for 10th question and graded assignment, g of x is not given. You told to ignore it, so we don't have to solve it, no, sir.
Yeah, so if you want to ignore it, you can ignore it. Like you will get mark. Okay, if you want to solve, you can solve by taking g of x is equal to mod x minus 1. Okay, if you want.
Okay.
Yeah. So I'll inform Vicky. So in the final grading, we'll not consider that question. Okay, so let me start.
Sir, you told that week 1 marks have told you that.
Yeah. It's on process. I have yesterday itself. I informed the respective person, and he told me they will sort it out. Okay, don't worry.
Thank you, sir.
Yeah. Okay, so yeah, so let me start. So the thing is, mostly we'll solve 5 questions. Okay, so I'll give you sometimes depend on the level of the question, and within that time you have to submit your answer. And okay, so you do it on your own. Okay, no need to tell me the answer. Okay, you just need to submit the answer. Okay, don't post in the chat box. No need to tell me. Okay, you just submit over there. I can see it. Okay, so I'll give, like, according to the level of the question, I'll give uh, some time. Okay, if the question is slightly difficult, then I may give some 10 minutes or maybe 15 minutes. Okay, so depend on the level of the question. Will like I'll give you the time, and don't give so don't send the answer in the chat box, or don't tell me the answer directly. Okay, if you want to tell the answer, then just submit it in this peer tech. Okay. Okay, so yeah, so basically, so if you open, then so in if you open in desktop, then you can see something like this in the left hand side, and if you open in the right mobile, then you can see something like this on whatever, like it's on the right hand side. Okay, so okay, just test the problem. So if you want to test it, okay, so yeah, so what is 20? So you can submit your answer. What is 21 divided by 7?
So actually it does not allow to submit. I think once we enter.
No, you just enter it. No need to submit. Okay. So you just enter it. Just write the number. No need to submit. Okay. Yeah, so.
And sir, just one question. Normally this solve with us, this is done one day before the deadline, right? So
yes.
For week 4, I think it is on the last day.
Week 4 tomorrow, right? Tomorrow is the deadline for week 4.
Tomorrow or today?
Tomorrow, right? Wednesday.
Okay. Then maybe I am wrong. Sure.
Yeah. So. Okay, so.
Sir, in this, are you only taking solve with us questions or doubts also?
Okay, so as I said, I'm going to solve 5 questions. Okay, so most likely I'll try to solve, like, complete it maybe max by 1.5 hours. So after that, I can take your questions maybe for 1 hour.
Okay, sir.
Yeah. Okay, so yeah. Just a minute. Oh, sorry. I guess I made a mistake. Yes, so sorry, I guess this code, okay, like so when I went there, this for your response, and when I came back, actually this now the code actually it's changed. So this, okay, so sorry, use this code again. You open and you use DYU UGU. Yeah, so you can see it here. in the top corner. Okay, DYUUGE. Okay, so let's go to the question. So the first question is, you have a polynomial. So the polynomial is x square plus 5 times x square plus 4. So this is your polynomial, and you have a set S, which basically denotes the set of all x intercept of the polynomial p of x, and you have another set R, which denotes the set of y intercept of the polynomial px. Okay, so you have two set. One set is S, which denotes the x intercept, and another set is R, which denotes the y intercept, and you need to find the cardinality of S union R. Okay, so whoever is so don't like just randomly don't submit your answer. So once you know what is the reason behind your answer, then only you submit. Like, don't do guesswork. Okay, maybe this question is slightly easy, so you can maybe take 3-4 minutes. So still now I got 20 responses.
Sir, what was going on? I was in stack class, that's why I joined late.
So this is your question. So you need to log in this joinpd.com, and
Yes.
you can use this code, like whatever is there in the top corner.
Yes, sir. I'm
Right
doing.
Yeah.
Just give a second. I'm doing.
Yeah, okay.
Sir, I have just joined. Can you show me the questions?
Can we discuss, or we need to wait like?
Just wait for maybe
Okay.
minutes. I just want to change the setting. So again, so when we are talking about the x-intercept, so in this course, when we're talking about x-intercept, means we're talking about in your plane, in your plane r square, right? We are not discussing in complex. Okay, so when you are going to solve this equation, you have to find all the roots that so all the roots that are in r, okay, that are in real number, okay, not in complex number, because whatever in this course we are doing, we're basically doing on real number. Okay.
So sir, for complex number we just take it as 0.
Yeah, so you don't have to consider the complex number. Okay, if you are getting complex number, then you discard it. Okay. Okay, so many of you gave, like, as I can see, many of you gave 1 as your answer, and I don't know if you gave 20. 5 is certainly not possible, and yeah, so mostly 3. Whoever gave 3, I guess.
Sir, it will be 3, na? X minus 2 plus 2 and y 20. So total 3.
No. Okay, so whoever
I'm confused.
Whoever gave 5, I guess they have considered also the complex root. Okay, I guess so. 5 is possible when you are considering complex root, and 1 is possible when you are considering only real roots. Okay, so anyone wants to share his solution, like how he got? Okay, so basically
Sir, I did it like x square plus
okay,
4
so
is equal to
just a minute,
okay.
just a minute. So basically, let me tell
Sir,
you
1. It will be 1. It will be 1.
Yeah, so
it will be 1. My mistake. It will be 1.
So yeah, so basically yeah, so anyone wants to share his or her solution, like how?
Yes, sir.
Yes, sir. This is px equal to x square plus 5, x square plus 4. Both are complex root. Because x square equal to minus 5, it will be in a complex domain, and x square equal to minus 4. So this will be also in complex domain. And if we say that intersection in y, then y is equal to 20. So there will be 1.
So you have, so this is your polynomial, right?
Yes.
So your polynomial is x square plus 5 times x square plus 4, right?
Yes,
so this is your polynomial. So, and what you want to know all the x and y x intercept. So for that, what you need to do?
To find the root.
0.
And
so
you have to find the root. X square plus
what
5.
value of x, the value of y is.
Okay, so just a minute. So someone was giving answer of this question. So just allow
x square,
yeah,
x square plus 5 into x square plus 4 is equal to 0.
No, you so
you have
basically
to find the roots.
Yeah, so
find the roots.
So basically, x intercept means what? The graph.
Roots. The where that a cut x-axis.
X-axis, right?
Yes,
so
where the graph cut x-axis.
That means the y coordinate is 0. Right? So y coordinate is 0 means my p of x is equal to 0.
0, right? Yes. Plus 4 is equal to 0. Right.
But as you can see, this cannot be 0. Okay, if you put any value of x, so this whatever this expression is, this cannot be 0. because x square plus 5 is always greater than equal to 5.
Yes, always greater than equal to 5.
And x square plus 4
always greater than equal to 4.
4. That means if I multiply x square plus 5 times x square plus 4, then it's always greater than equal to 20.
20.
So that means this whatever this polynomial, this so if you take any value of x, this polynomial will never give you 0. Okay.
Yes.
So that means the number of y-intercept. So this set, whatever this set is, right? So this set is the x-intercept. So S is an empty set, right?
Yes.
So S is an empty set. So the cardinal, so S is empty. Right. So next thing is you need to compute
y. Putting x equal to 0, we have to find y.
So
y intersection.
Okay, so let me do it. So the next thing is y is basically R, the set R is basically your y-intercept. So y-intercept means the point where the function touches the y-axis. That means your x coordinate is 0, right?
Yes.
So x coordinate is 0 means you have to substitute x equal to 0 in this equation. So once you substitute x equal to 0, what you will get? You will get
20.
Y equal to 5 times 4, which is
20.
20, right? So then your y-intercept is basically your point. Y-intercept is this set. This is 0, 20, right? This is your y-intercept. Because this is where at 0, 20, the whatever this curve passes through y-axis, right? So this, now I know my set S, I know my set R. So if I take S union R, so this is basically 0, 20. And this, as you can see, this is basically, it's a singleton set, and the cardinality of S union R is 1.
Sorry, I didn't get that thing. Why you are taking 0?
No, so what is your y-intercept?
When x is 0.
This is how we write intercept.
What is your?
But x is 0, y is 20. That's why you're saying the cardinality 2. Okay. 1, 0, 20.
This is a point, right?
Now get it. There's a point.
This is a point in your xy plane, right?
Yes, now I get it.
So you want
this is a coordinate you want to mean. That's why
exactly.
I didn't get it.
So basically you want, so
we need to check the elements of the elements actually.
Correct.
Right,
so
sir?
basically you want to find the point where the graph crosses this y-axis, right? So then if the graph crosses this y-axis, so then you will get a tuple, right? So you will get a tuple. You want to find the coordinate of this point, whatever this point. So obviously you will get a tuple. So in this case, this coordinate is basically 0,
20. Yes, I got it.
Okay, so
can you explain how S is empty?
Sorry?
Can you explain why S is an empty set?
Okay, you want me to explain why x is equal to S is empty. So okay, so before that, tell me, what do you mean by x-intercept?
The one where the line touches x.
Sorry?
The points where the line touches x-axis.
Where is so from where you got line?
I'm sorry, parabola.
From where you got parabola? This is, we are talking about this polynomial, right? This is not this is not a line, as well as this is not a parabola. So basically we are talking about the x-intercept of this polynomial p of x, right? So that means we need to find the points where this polynomial p of x crosses x-axis, right? So we need to find the point where this polynomial, whatever this is, maybe this polynomial p of x, okay, we need to find the point where this polynomial crosses x-axis. Okay, so we need to find this point. So in x-axis, whatever this coordinate is, so I can say that, so whatever this coordinate of this point is, the y coordinate of this point is always 0, right? In x-axis, value of y is always 0, right? So to get the value of x, I need to substitute that y equal to 0, right? So this is x, this is p of x, right? This is p of x, which is y, right? And since here the value of y equal to 0, so that means this p of x is equal to 0. So what is p of x? P of x is x square plus 5 into x square plus 4. And at this point, p of x is 0. This is 0, right?
Sir, what he was asking, so it is having two roots, right? It is intersecting with the x-axis at two places,
No,
like +2 and -2.
Sorry?
It is intersecting with x-axis at +2 and -2, right?
Why?
Because
can I say something?
Just a minute. Let me answer his question. So yeah.
So the as you told, we are considering that x square plus 4. That factor.
No, my question is, you are saying the function. So the graph of the function intersect this x-axis at -2 and +2, right?
Right.
So that means if I substitute +2 and -2 in that polynomial, I should get 0, right?
Right.
So now you try to substitute it in the polynomial, whether you are getting 0 or not. If you substitute 2 in this polynomial, whether p of 2 is 0?
No.
So then how you can say that this equation x square plus 4, this equation doesn't have any real root. Okay, so the root, if you try to compute the root, the root of this equation is basically plus or minus 2i. Okay, you will get complex root. This equation, this x square plus 4, this equation has no real root. Okay, so whatever you are suggesting, that's 2 and -2. So if you substitute in this equation, then you are going to get something which is greater than 0. Okay. So basically, our main aim is to find the x-intercept. Okay, so which is equivalent to find the roots of this polynomial. Okay, and we prove like one. So since we know x square is always greater than 0, right? That means x square plus 5 is always greater than equal to 5. And similarly, x square plus 4 is always greater than equal to 4. And if I multiply x square plus 5 times x square plus 4, this is always greater than equal to 20, right? That means this polynomial can never give you 0. That means this polynomial don't have any x-intercept. Okay, so that means this set S is empty. Now is it clear?
Sir,
Okay.
can we say
Sir,
that
just one point, sir. X square plus 4 is greater than equal to 4. Can you explain it? Basically, we put the 0 to find the roots.
Sorry?
Here we are saying x square plus 5 is greater than equal to 5. When we want the root for this equation, we put 0 basically. X square plus 5 into x square plus 4 is greater than equal to 0. Like that.
No, but just now I proved, right? It cannot. So this whatever this polynomial can never give you 0, right? Because I proved that this polynomial, the value of the polynomial, whatever input, whatever input you give, okay, so whatever value of x you put in that polynomial, you will always get something which is greater than 20.
Yes,
right?
definitely.
That means
right.
you will never get 0, right?
Yeah.
That means the polynomial don't have any roots, right?
Yeah.
So that
Got
means
it.
the set S is empty.
Okay.
So, but here the polynomial has complex roots.
But we are not talking about complex root. We want to only find the real roots.
So can we say that this graph of this polynomial, the graph of this polynomial do not intersect x-axis?
Yeah.
This question is concluding that only, no? If R set is empty, that means
this S set is empty.
S set is empty. Yes, sorry, S
Yeah.
set is empty. So it is not intersecting the graph of this polynomial. Do not intersect.
No, it will never intersect x-axis.
Okay, okay.
Yeah. So since S is empty, that means we don't have any x-intercept. That means if you try to draw the graph of the polynomial, let's say you try to draw it in Desmos, if you draw it, it will never intercept in x. It will never intercept x-axis. Okay, because this polynomial don't have any x-intercept.
Sir, the thing is like from your earlier explanation, it cannot be presented in 2 dimensions, right? If it is more dimension, maybe we can picturize that how it is intercept. I mean,
no, I didn't say anything like this.
Okay, okay.
Yeah.
So just one question. In option, if I have a option 2 type for this equation, we have an option 1, and another option is like including the complex root also to find the S union R. That time, which option I will choose, 1 or another one?
No, we will not ask you about complex roots. Okay, because we are not going to deal with complex number.
If suppose this type of option in a present in a question, we can go with
complex root. Yeah, then you should, because this polynomial has complex roots. Okay, so but the thing is, since in this course we are only dealing with real roots, and this polynomial don't have any real roots, that's why this whatever this set S is, that is basically empty.
Okay.
Okay, so yeah. Okay, so let's go to the next question. Suppose you have, let's say, 3 roots of this polynomial a, b, c. These are 3 roots of this polynomial x cube plus 7x minus 1, and what I know about the roots, the relation between the roots, the sum of the roots are sum of the roots of the polynomial is basically 0. Okay, I know a, b, c. These are 3 roots of this polynomial, and one more thing I know, that sum of a, b, c is 0. Then what is the value of a cube plus b cube plus c cube? Okay.
Sir,
yes.
This will be 0.
Which one?
Okay.
So you are telling me the answer or what?
Yes.
No,
yes.
I don't want answer from you. Like you.
Okay.
Please submit it like using that code.
Done, sir.
Okay, you submit it. Like I can see it from the responses. Once I see, okay, I got enough responses, then I'll go for the sub. Just type it. Just type. No need to submit your answer. Just type it there. It will automatically. I can see it. Like I can see your answer.
Sir, where to submit the answer, sir?
This joinpd.com, and you have to go to this joinpd.com, then you have to use this code like DYUUGU. Then only you can submit that. Okay, so I guess now I can. Three, 4, 3. Okay, so 0. Okay, many of you gave 3, and after that, so majority is 3. After that, maybe 0, and few of them also gave submitted 1 as their answer. So okay, so the correct answer is 3. Okay, so I guess most of you gave the correct answer. So yeah, so I want one of you to tell me why 3 is the correct answer. So okay, so let me read the question once again. So you have a polynomial x cube plus 7x minus 1, and what I know that this polynomial has 3 roots, a, b, c, and I know that sum of the 3 roots, that is a plus b plus c, is 0. Then what I need to do, I need to find the value of a cube plus b cube plus c cube. Okay, my polynomial is x cube plus 7x minus 1. Okay, so anyone want to share the solution?
Yes, sir. The
No,
formula.
no. Sorry,
Okay.
I guess you have already.
Yes, sir. Yes,
okay.
I did.
So anyone else?
Yes, sir.
Yes, sir.
Okay, yeah. So please, one of
Yes,
you.
Yes,
So the
polynomial is x cube minus 7x minus 1. And we are told that the sum of roots is 0, which implies that a plus b plus c is 0. So what I did was I put the roots which are given, that is a, b, and c, in the polynomial, which gave me a cube minus 7a minus 1 and 0. The second equation was b cube plus 7a minus 1 equals to 0, and c cube plus 7c minus 1 equals to 0. I added these. I did the three equations, which gave me a cube plus b cube plus c cube plus 7.
Correct.
Whatever b plus c, which is 0, and minus 3, which gives the answer.
Correct. Yeah. Whatever, like this is what I'm going to do. Like whatever he suggested, like. So this is exactly I'm going to do. So it is, so this is my polynomial, and it is given that, so two things are given. So the first one is A, comma B, comma C. These are three roots of the polynomial P of X. Right. So this is the first information, and the second one is the sum of these three roots is basically 0. That is A plus B plus C equal to 0. And what I need to do, I need to find so my aim is to find AQ plus BQ plus CQ. Okay, this is what I need to find. Okay, so the first information is A, B, C. They are roots of the polynomial, right? So if A is a root of a polynomial, that means P of A is 0, right? If A is a root of the polynomial, then certainly P of A is 0. So now if I substitute A in this equation, so instead of X, if I write A, then what I will get? I will get AQ plus 7B minus 1 equal to 0, right? Sorry, not 7B, 7A. So this is what I will get once I substitute A in my polynomial. Okay, so the next root is B, which, so again, by the same logic, I should get P of B as 0, and which is same as BQ plus 7B minus 1 equal to 0. And similarly, I should get P of C is 0, which is same as CQ plus 7C minus 1 equal to 0. And as you can see, I want to know AQ plus BQ plus CQ, right? So I have AQ here, I have BQ here, I have CQ here. Okay, so let's add these three equations. Okay, once I add these three equations, so I'll add equation 1. This is my equation 1, this is my equation 2, this is my equation 3. So equation 1, so let me add equation 2 and equation 3. So once I add these three equations, so I will get AQ plus BQ plus CQ plus 7A plus 7B plus 7C minus 3, which is 0, right? This is what we get once we add these three equations. Okay, so we want to know this value, right? So we can take these things to the right hand side. So this is basically AQ plus BQ plus CQ.
May I ask a doubt?
Yeah, please.
Sir, if we expand that AQ plus BQ plus CQ, like in the formula, like we will get A plus B plus C, one factor, and then A square plus B square plus C square, like there is a formula, right? AQ
yeah, that is, you have to do a lot of things. Okay, so if you use this method, you can get it using the formula, but that is too lengthy. Okay.
But sir, if we substitute in formula, we are getting 0, sir.
Yeah, if we use the formula, we get 0. So I was just trying to understand what is wrong there. Like if we use the formula, because in the formula, A plus B plus C is equal to 0. 0 into anything is 0. So
no, you are doing that is actually A plus. So
that is a cube plus b cube plus c cube is equal to a plus b plus c into something plus 3abc.
Yes. So it's not like that. That formula is not that a plus b plus c times something. Okay.
Yes.
Sir, I have used the
then
formula, sir. I
if
got
you
the
then
correct answer.
a cube plus b cube plus c cube is equal to 3abc.
Okay. So let me complete it. So just two more steps. Okay. So a cube plus b cube plus c cube. So this is basically 7a. So let me take 7 out of this expression. This expression 7 times a plus b plus c minus 7 times a plus b plus c plus 3. And the second condition says that the sum of the roots is 0. That is a plus b plus c is 0. Right. So now this is 0. So once this is 0, the value is basically 3. Okay. No, the formula is basically something else as far as I remember, because basically you are using this formula, right? This a plus b plus c whole cube formula, right?
Sir, I have used the formula, sir. I got the correct answer.
Yeah, so as far as I remember, if you use the formula also, you will get the correct answer. Okay,
yes,
but if you are doing it using the formula, then probably you have to use you have to write little more. Okay.
But sir, the formula is for a cube plus b cube plus c cube is equal to a plus b plus c of a square plus b square plus c square minus ab minus bc minus ca, no sir. So if a plus b plus c is 0, 0 into anything would be 0.
Sorry, what is your formula? A cube plus b cube plus c cube is what?
A plus b plus c into
a plus b plus c
into a square plus b square plus c square minus
a square plus b square
plus c square
minus
ab
minus
just a minute minus a
minus ab minus bc minus ca
minus ca.
So this formula is incorrect, sir.
That is certainly
minus 3abc on the LHS.
It's certainly incorrect. So try to multiply this one with this one, okay, and try to see whether you are getting this thing. Okay, so basically this formula, whatever formula you get from this part like this, so there is a formula for a plus b plus c whole cube, right?
Yes, sir.
And using this, so if you expand it, you will get something like a cube plus b cube plus c cube and
plus 3.
Whatever you will get apart from that, you will get this. Okay, whatever
yes,
is yeah.
In the before formula, I missed minus 3abc on the left hand side.
So yeah, so whatever, so finally you will get a cube plus b cube plus c cube is nothing but a plus b plus c whole cube minus whatever this part, the remaining part. So this is the correct formula.
Yes, sir.
So certainly, yeah. So maybe, yeah. Someone already posted it in the chat box. You can check. Like this is probably the correct formula for this. Yeah. So this, but again, this if you are going to use this formula, then it's slightly complicated. Okay, it's not that difficult, but it will take a little more time. Okay, but if you are going to use this method, then more or less it's once you see the equation from there, you can get the answer. Okay, any doubt from this question?
So just explain me the step of minus 7a plus b plus c.
No, what we are doing. So what we are doing here, we have 3 equations, right? This part is clear.
Yes, sir.
So then we are adding these 3 equations. So
yes,
if we add these 3 equations, so this is what we get, right? A cube plus b cube plus c cube plus 7a plus 7b plus 7c minus 3 equal to 0, right?
Yes, sir.
So then you take 7. If you take 7 common from here, A plus B plus C, right?
Yes, sir.
And in the question, if you go back and see the question, there is one more condition, right? The sum of the roots is 0.
Okay, sir.
Right? Sum of the roots is 0.
Yes,
that
sir.
means A plus B plus C is 0.
Yes.
Right? So then you will get 0. So this 7A plus 7B plus 7C is nothing but 0. Okay. So since 7A plus 7B plus 7C is 0, that means you are left with only 3, right?
Yes, sir.
So A
Yes,
plus,
sir.
yeah. So okay. So let's go back to next question. So the next question is, so you have bunch of statement, and you need to tell which of the following statement are correct. Okay, so you have 4 statements. So you need to mention which of the following statement are correct. Okay. So the first statement is you can have infinitely many polynomials. So there are infinitely many polynomials of degree 3, and all of the polynomials. So all of the polynomials have a common property. So what is that property? That P of 4 is 0, P of 7 is 0, P of 5 is 0. Okay, so that means 4, 7, 5. These are the roots of all the polynomials. So if there are infinitely many, so you need to find whether there are infinitely many polynomials. So with the common property, that is P of 4 is equal to 0, P of 7 equal to 0, and P of 5 equal to 0. So that is the statement 1. Okay. So in the statement 2, it's slightly incomplete. Okay. So the statement 2, okay, let me say it properly. So the statement 2, basically, if x minus 2 is a factor of x cube minus 2x plus 1, then the value of k is 10. Okay, the value of k is 10. So you have to take k as 10, and according to that, you have to valid. So you have to check whether the statement is correct or not. Okay, first,
can you repeat the second statement
so
again?
The second statement is if x minus 2 is a factor of x cube minus 2x plus k, then the value of k is 10. Okay, only the 10 is missing. Okay, so the value of k is 10. Okay, only the 10 is
So we
missing.
have to choose the right option or wrong option?
Correct option. Okay.
Correct option.
Okay, let me repeat. In the second statement, the value of k is 10. Okay, in the second option, value of, let me write it. Value of k is 10. Okay. Yeah. So you can check the chat box. So the third statement is number of turning points of the function. This function is a polynomial function. So that function P of x is x plus 5 into x minus 3 times x square minus 4 is 3. Okay. So the third statement is number of turning points of the function P of x is whatever this is.
So if I may say something.
Huh.
Actually, the answers are not taking more than one answer, sir. It's actually functioning as an MCQ.
Okay, got it. Okay, so then okay, sorry, then I missed it. So
it is MCQ.
Yeah, so then you try to click on single answer. Okay, do if there are two. So if there are two options,
I choose only one option.
Yeah, you choose only one option. Okay.
Okay.
So the third statement is the fourth statement is you have a function g of x which is minus 0.01 times 2 minus x times x minus 8 times x minus 12 times 16 minus x, and this says this function is positive in the given domain, and the domain is the interval 2, 8 union 12, 16. Okay, so next, so don't write your answer in the chat box. Okay, so don't write your answer in the chat box, and also don't tell me the answer. Okay. So once I start solving the question, then you can post your answer in the chat box. So when you are writing your answer, then basically you are discouraging other people to solve this question. Okay, so as you can see, like most of you gave statement 1, statement 3.
Excuse me, sir. Just wanted to ask. I got disconnected in between. For statement number 2, the value
of k is 10.
Okay, 10. Okay.
Yes, yes.
I'm just giving the answer.
Yeah, please.
Excuse me, sir. Sir, actually in graded assignment question number 3, the last option it is given, the function g of x something is given, is positive in restricted domain infinity comma minus 3 it is given, sir. How can the domain be defined infinity? It should be minus infinity comma minus 3 or like minus 3 comma.
We'll come to that once we finish this, we'll come.
Okay, sir. Thank you.
Yeah. Okay, so as I can see, like most of you gave statement 1 since it's not taking more than one option. So yeah, so statement 1 and statement, so yes, few of you, 3 suggested statement B, and for D 6 responses. Yeah, mostly statement A and statement C. Well, basically statement A and C, statement 1 and statement 3, they are correct. So statement 1 and statement 3, and I guess statement 4 is also correct. Okay, I have to check. As far as I remember, statement 4 is also correct.
Statement 4, this boundary is positive, sir. As per my graph. 2, 8 and 12, 16, this as per my graph, this is positive.
Yes, okay. We'll try to. So basically statement 1, statement 2, I guess is not correct. Statement 1, statement
2 is not correct.
Yeah, statement 3 and statement 4.
Yes, sir. The three options are correct.
Yes.
Sir, how statement 3 is correct?
Yeah, we'll come to that. Don't worry, we'll come. We'll solve each option. Okay, so okay, so what about option 1? So what is your answer for option 1? If it is correct, tell me your explanation. If it is not correct, like also tell me why it is not correct.
So
Anyone?
Many polynomials can have the same roots of degree same based on the term what it will have association. The polynomial will differ. So it may have many polynomials.
Yeah. So how no, this whatever you are saying, you are basically saying vaguely. So can you tell me like few like infinitely many polynomials and they have the same property, the property that is mentioned in statement 1. So basically it's saying that there are infinite. So basically it tells you that there are infinitely many polynomial with this property that P of 4 is 0, P of 7 is 0, and P of 5 is. Okay,
Sir,
so
may I explain?
yes, please.
Because it is a cubical polynomial, its general form will be ax cube plus bx square plus cx plus d.
Yes, correct.
And here it is given that three and it has 3 roots because at 3 places p of x is equal to 0. But constant term we cannot find.
P of 4 is 0, P of 5 is 0, and P of 7 is 0, right?
Using this information, we can find 3 coefficients.
Yes.
But fourth constant coefficient we can't find with this information.
How you can get this 3 coefficient?
Actually, we can using the general equation ax cube plus bx square plus cx plus d is equal to 0.
So continue.
P of 4 is equal to 0 means in place of x, if we put 4, then that should be equal to 0. Then we get one equation related to a, b, c, and d. And in that polynomial, if you substitute 5 in place of x, we'll be getting another equation for a, b, c, and d. And in place of x, if we put 7, we get another equation containing these 4 coefficients.
So from there, how you will get the value of, so suppose your cubic polynomial is, let's say, x cube plus bx square plus cx plus d equal to 0, right?
Yes, sir.
This is your polynomial. So suppose you substitute 4. So a times 4 cube plus b times 4 square plus c times 4 plus d equal to 0. And the next equation, what you will get? You get a times 5 cube, b times 5 square plus c times 5 plus d equal to 0. And similarly, you will get something like.
Similarly, we will get another equation. But we
So
have here four unknowns are there, A, B, C, and D.
No, yeah. So A, B, C, D. You have 4 unknowns, right? So from here, how you will get the value of A, B, C?
So that is yes, sir. To solve to get 4 coefficients, we need 4 equations. But here only 3 values are possible.
You actually from this thing.
Can I answer, sir?
Yes.
According to me, since 4, 5, 7 are the roots.
So are you going to answer in this current method, the method she suggested?
No, sir.
We need to know the intercept also, sir.
Okay,
we
so
need to y intercept.
Yeah, so the thing is, okay, let me complete it. So basically, you can solve it. Okay, you can solve this equation. Okay, so you can solve this equation, but again, you need something else, like you need linear algebra. You have to apply this Gauss elimination method to solve this question. Okay, so
sir,
so this equation will have infinitely many solutions. Okay, that is correct. So from there you can say that, okay, so you have infinitely many solutions for this equation. That means I have infinitely many values for, so I have infinitely many A, B, C, D which satisfy these three equations. And since I have infinitely many choices for A, B, C, D, I'll get infinitely many cubic polynomials. Okay, but again, so
sir, here we there is in this equation we can say that if we form like this, like x minus 4 into x minus 5 into x minus
that is what I'm not, that is another way, but I'm talking about this particular thing, like whatever the way C suggested.
Yes,
so,
I'm trying to say by the stretch factor.
Yeah, that is the way that I was planning to solve. But okay, so since if you want to do this, so using this method you can do it. It's not that you can't do it, so you can do it. But okay, the main problem is to solve this system. So you have three systems, right? So three equations but four variables. So you can solve this system, but okay, to solve this system you need Gauss elimination. Okay, so that basically you are going to study in maths too. Okay, so another way of solving this equation is basically since 4 is a root, so that means x minus 4 is a factor of this polynomial p of x. And since 5 is a root, that means x minus 5 is also a factor of p of x. And similarly, x minus 7 is also a factor of p of x, right? P of x. So since p of x is cubic, you have, this is p of x is basically x minus 4, x minus 5, x minus 7. But we don't know the stretch factor of this polynomial. So I have to consider some. And this a varies over real. Okay. So for different value of a, I will get a different polynomial. Okay.
Sir, we can also say that we don't know the multiplicity of that roots.
You can change the multiplicity. Okay. The problem is if you change the multiplicity, then you will end up with a polynomial of degree more than 3.
But the points will be same, but we can draw these points with the change of multiplicity.
What is statement 1? There are infinitely many polynomials p of x of degree 3.
Okay,
right?
okay. Right. To stretch factor, we can do.
So if you change
that part, I missed.
If you change the multiplicity of one of them, okay, so you will get a polynomial of degree more than 3, right?
More than 3, right?
But you want a polynomial of degree 3, so you cannot.
Yes.
You cannot
change the multiplicity.
So definitely this polynomial.
I just missed that part. That's right.
So the polynomial should be in this form. That is a times x minus 4, x minus 5, and x minus 7. Since I don't know the values of a, so for different of value a, I will get different polynomials. So basically, I can have infinitely many polynomials. For example, this p1x, which is nothing but x minus 4, x minus 5. X minus 7. Okay, so the next one I can take. So then the next one I can take p2x. So this is 2 instead of a, I'm taking 2, x minus 4, x minus 5, x minus 7. And similarly, you can keep on taking all the natural number in place of this a. So here I can take 2, then 3.
Even we can take the negative also.
How
you can take what?
Why are we taking, sir, here 2, 3, 4, and
because we want to produce infinitely many polynomials, and with this property, that is p of 4 equal to 0, p of 7 equal to 0, p of 5 equal to 0.
Here, actually using this roots, we are asking, using these roots, can we produce many polynomials, or only many polynomials for this?
No. See, the thing is okay, so whatever you are going to do, you have to do according to the question, right? So the statement 1 is basically saying that there are infinitely many polynomials of degree 3 such that p of 4 equal to 0, p of 7 equal to 0, p of 5 equal to 0. Okay, so if you can produce infinitely many polynomials with this property, then you can say that this statement is correct, right? Yes. So right. If you can produce, then you have to prove it that you cannot produce. Then you can say that statement 1 is incorrect. Okay, so what I am basically doing, I am trying to say that statement 1 is correct. So to say statement 1 is correct, then what I have to do, I have to produce infinitely many polynomials with the given property, right? So yes, that is precisely I am doing. I am trying to produce infinitely many polynomials, different polynomials. So P1, P2, they're all different. Okay, so there I am trying to produce infinitely many different polynomials with the given property. Then I can say that my statement 1 is correct.
So, but if I have a y-intercept component given,
no, that is a different question. That is a different question. Now you're going. So now you're going to the graded assignment question. Okay, so that is a different question. So that you need to think.
Okay,
sir. Sir, if we have a value of p as for negative, then
sorry.
If we have value of p as negative, then it would affect the answer or not?
No, can you repeat? I can't hear.
If we have value of p negative, then it will affect the answer or not?
Can someone else repeat his question, like what asking?
I am saying that if we have p of x value is negative, then what will be the answer? It will still same.
P of x value is negative.
Yes, sir.
Always negative.
Yes. All three given will be negative or only one?
No,
like can you tell me the question little
it's like p of x root, p of x, root of this equation like 4 5 7 root of this -4 -5 -7, like that.
Yeah,
answer is same, I think, sir.
So can you repeat the question? You want so instead of 4 you want p of -4 to be 0?
Yes, sir. Yes.
P of -5, then you will get the same thing, right? Instead of -4 4 -5 4 5 7, you have to do it for -4 -5 -7. So instead of this you will get this, right? Plus x plus 4 x plus 5 x plus 7, and you can do the same trick over here. Okay.
The only difference is the polynomial will be the other side of the y-axis.
What do you mean by that?
So
the roots, the roots, it will cross. So in one, so in the first polynomial, it will cross here. The x-intercept will be somewhere here, and in the second polynomial, it will be on the left side.
Right.
Okay, I understand.
Okay, so since someone asked me like so if one more condition will
मेरे को टाइम लगेगा 10 बज जाएगा.
So if suppose one more condition is given, then
actually I got it clear. Like I was having doubt there.
Yeah. So
now
try to think if
I got it.
So now we can so since this a value is not fixed, I can rotate it. So I can assign any value to a. Okay, see, suppose if one more condition, that condition whatever is given in the graded assignment is given, can you rotate the value of a according to your choice? Okay, that is the question I want to ask. Okay, so this question should, if you try to think about this question, then this will give you the answer. Okay, so okay, so next thing is, if x minus 2 is a factor of this polynomial x q minus 2x plus k, what is the value of k? Okay. So this says x minus 2. So the next is x minus 2 is a factor of x cube minus 2x plus k, then the value of k is 10. Okay, this is the statement. I want to know whether this statement is correct or not. So it says that x minus 2 is a factor of this, right? That means if x minus 2 is a factor of this polynomial p of x,
the x minus 2 will be a root of this equation.
Then not x minus 2, then basically it says 2 is a root of this polynomial p
2
of x.
is the equation, right?
So if it says if x minus 2 divides p of x, that basically means p of x is x minus 2 into some polynomial, let's say g of x, right? If x minus 2 divides p of x, then I can write p of x is basically x minus 2 times some g of x. And if I put p of 2, then what I will get? 2 minus 2 into g of 2, which is 0, right? That means p of 2 is 0. Okay, so let's try to substitute 2 in this polynomial. So what I will get? 8 2q, right? 2q, which is 8, then 4, then plus k is 0. That means the value of k is minus. Okay. So that's why the second option is incorrect. So is it clear, the second option, why the second option is incorrect?
Yes, sir.
Okay.
K equal to minus.
So in this equation, sir, one thing I have solved in another way. In this equation, we put the value of 10. After that, I will divide by x minus 2. It is not divided properly.
Correct. That is also you can use that method. Yeah.
Okay.
Yeah, that is correct. So if it's basically you are trying to do the contrapositive of the statement.
Sir, this like this approach you took actually didn't understand this, what you tried to do here.
No, which part is not clear?
So x minus 2 is one of the factor. So x minus 2 in the rest and the rest of the factor, the other part.
So that means x minus 2 is a factor means what? X minus 2 divide that polynomial, right?
Correct.
So then if the polynomial x minus 2 divide that polynomial, then I can write in this way, right? X minus 2 times something.
Correct.
Right. So so this basically implies that p of 2 is 0.
P of 2 is 0. Yes.
So then you just substitute the value of 2 in this polynomial p of x, then you should get 0, right? If you substitute since p of 2 is 0, if you substitute the value of 2 in this polynomial p of x, then you should get 0, right?
Right.
So then what we got? That is 8 minus 4 plus k, which is 0. This is basically p of 2, right? Which is 0. That means k equal to minus 4.
Okay.
Okay, so the next statement is the number of turning points of this function p of x is 3. Okay, so I guess this is one of this SAR. I guess he explained this kind of example in his lecture. So my polynomial is basically what? This is if you see, this is x plus 5, x minus 3, x plus 5, x minus 3, and
x minus 2 and x plus 2.
Sorry, this is 4, right?
Yes, x minus 2 and x plus 2.
So here we can count like that, x square total. Just we add the power, then minus 1.
No, that basically, see, if a polynomial, if you are taking a polynomial of degree n, okay. So a polynomial of degree n can have at most.
Yeah, at most
n minus 1 critical point. Turning points.
Turning point.
But I'm not asking here. I'm not asking here at most. Okay, so I'm asking the precise number. Okay,
yeah.
So what you are giving when you are saying that a polynomial of degree n can have at most n minus 1 turning points, then basically you are giving me upper bound. Okay,
yeah.
You are not giving me the actual number of turning points. Okay, so this can be some number which is less than equal to n minus 1. Okay, so you are not giving me the precise value. You are just giving me the upper bound. Okay, so if you see in question number 3, I'm basically asking you the precise number. Okay, the number of turning points of this is 3. That is the precise number. I'm not saying that the upper bound of number of turning point of P of X is 3. That is not I'm asking. I'm asking you the precise number. Okay,
that is indirectly the roots. There are 3 roots, and we can say that there are 3.
Actually, not 3 roots. Actually, the one way to say is this polynomial has 4 distinct
roots.
Okay, 4 distinct. Since this polynomial has 4 distinct roots, that means it has 3 turning points.
Yes.
Okay. Otherwise, you can basically you can draw the graph of this polynomial, and after that you can see like why. Basically, if you try to draw this graph, it should be something like this. So this is 2. This is 3. This is minus 2. This is minus 5, right? These are the 4 roots, right? And this is a degree 4 polynomial. So as x tends to infinity, and if you take the first leading term, this is basically x to the power 4 plus something else. And as x tends to infinity, P of x tends to infinity, right?
Yes.
So then it will come from this side. Again, it will cross this because this multiplicity of 3 is 1. Then again, it will cross 2 and cross minus 2. So this is a turning point. This is a turning point. This is another turning point, and this is another. Okay, so you have 3 turning points. Okay.
Here, A also plays a role, right?
So sorry.
A.
Huh?
A value, A x to the power of n. What you said is n is even.
Yes.
So A also plays a vital role over here, right?
So here A is 1. Yeah.
Okay.
Yeah, certainly A plays a vital role, but here in this case, here A is 1. So yeah.
Got it. Thank you.
Certainly, I don't think it will affect the turning points. It will change the shape of the graph.
Yeah, it will decide the sharpness, how like how sharp or how smooth the.
Yes. Okay, so the next
one
thing.
Just one thing, sir. Here in this graph, can I conclude like this? For exact turning points, total number of roots minus 1. Is it correct for every statement or not?
No.
Okay.
No, that you can apply when you have all the roots are distinct. Okay. In that case, you can say. Okay. So
for distinct root,
when you have a polynomial of degree n and you are getting n distinct roots. Okay. In that case, you can say that you will get n minus 1 number of turning points. Okay.
In this scenario, minus 5 is distinct, minus 2 is distinct, 2.
No, because in this case, all the roots are distinct, so you can apply it. Okay, for this case you can apply it, but that is not true in general.
Okay.
We can simply put it in graph and we can assume.
Yeah. That is one way. But if you want to, if you want to apply this method, this formula, like whatever for degree n polynomial, the number of turning points is n minus 1. that you can apply when you have a degree n polynomial and all the roots of that polynomial are distinct. Then you can say that, okay, I'll get the number of turning points is basically n minus 2. Okay, so the next question is, you have this polynomial like g of x, which is, let me write it. So g of x is what? Minus 0.01. Then I have 2 minus x. Then I have x minus 8.
X minus 12.
12, 16 minus x. Okay. X minus 12.
X minus 16.
16 minus x, right? And I want to know whether this polynomial is positive. So as you can see, the function g of x, whatever this function is, this polynomial is positive in the restricted domain. So you know, see, the domain of this polynomial is R. Okay, but I don't care how this polynomial behaves apart from this region, that interval, this 2, 8 union 12, 16. I don't care how they behave apart from this given set. I only want to know how they behave in the given region. Okay.
In the given region, it is coming as negative, but I think someone told that it is positive.
Okay, let me check. Like I thought it's positive, but let me check. Okay. So I want to know whether in this given region, whether this polynomial is positive or not. Okay. So we'll try to draw the graph. So first I'll try to convert this polynomial. So as you can see, you have something like 2 minus x here, correct? And you have 16 minus x here, right? So what I will do, I'll change
x minus 2 and x minus 16.
So if I change this into x minus 2, then what I have to write? Minus of x minus 2, right? So 2 minus x, I can write it as minus of x minus 2, and this I can write it as minus x minus 16. And eventually this and this minus I can cancel, and I can write plus. So eventually what I will get this is x minus 2 and x minus 8, x minus 12, and x minus 16, correct? So these are basically, they're same, right? So I'm just canceling out this minus and this minus. So what is the leading term of this polynomial? This is basically minus 0.01 times x power 4, right? This is degree 4 polynomial, right? And after that some remaining terms which we don't care. If you want to draw the graph, certainly we can ignore all these things. Okay, we just need to concentrate on the leading term. Okay, so as you can see, as x tends to plus infinity, this x power 4 tends to plus infinity. But I have one more. See this there is a coefficient of x4. Okay, I have to also check. So then
is minus here.
Yeah, so then 0.01 x power 4 tends to minus infinity, because I'm taking some negative number and I'm multiplying with some positive number, so I should get something negative. So this thing will tends to minus infinity. That means my polynomial, whatever this polynomial g of x, this tends to minus infinity. So as x tends to plus infinity, g of x tends to minus infinity, right? So let's try to now draw the graph.
Sir, like in the other other session, I think I came to know that if the leading term is negative, then for the polynomial, it will have the last 2 point as open arm upwards. So it is a upward parabola. The ending
This is
2
not
points.
a parabola.
Yeah, it is not a parabola, but it is a even number. So both the last 2 points will have open arm, like upwards.
Yes. Basically, not upwards. I guess it's downward because you have negative here, right?
No, it is negative means it will have the downward parabola, right?
Not parabola. Don't use parabola.
I'm sorry, it is not parabola, but if it is negative means it will have upward.
Yes. So this is 16.
That is for odd powers.
Yeah. So let me draw like this.
That at 2 and 16, it will go upward and it is to infinite.
2, 8, 12, 16, right? And as you can see, as x tends to infinity, g of x tends to minus infinity, right? So it will come from below. Okay. So it will come from below, then it will cross, because multiplicity of 16 is 1, it will cross the x-axis, then again it will go and it will come down, again it will cross this point, again it will go up, and again it will cut to, again it will go down. Okay.
Sir, I think this we are thinking in opposite. Let's say if I take a parabola, a positive parabola, like what I mean to say.
Okay, so again, you are using, don't use,
I understand. But if I want to isolate this, just to understand whether this at point 16 should come from downside or offside, okay? So if I take a parabola, say for example, x square is equal to 0, how that parabola would be? That parabola would be downward parabola, right?
X square equal to 0.
Right.
X square equal to 0. Okay, so this is x square equal to 0 is not a parabola. It's basically x equal to 0. So you are taking something f of x equal to x square, right?
Right.
So what is the graph of this parabola?
Okay, let's say
this one, right? This is so the graph will look like this. Okay, so one more thing I will suggest, please watch the last live session. So in the first 1 hour, actually I have discussed how you can draw the graph of a polynomial. Okay,
sir,
so
only point is what I was thinking is that point 6 and point 2, it will not come from downside, it will come from the upside. That is
why? Because see, the thing is here what we are getting as x tends to infinity. Okay, so we are getting g of x tends to minus infinity, right?
The leading term is negative, right?
Yes. No, from using that only what we got, since the leading term is negative, finally what we got, as x tends to infinity, g of x. So do you agree this on this, whatever I have done here, as x tends to infinity, g of x tends to minus infinity? Do you agree or not?
Yeah, that part I agree.
Then how it can come from this direction? Because if you are saying that it will come from this direction, then basically you are saying the complete opposite thing. As x tends to infinity, g of x tends to plus infinity. But that is not the case here, right? So it can't come from the offside. It has to come from the below part. Right. When you are saying it will come from this side, then basically you are saying that as x tends to plus infinity, you are saying g of x tends to plus infinity. But we are getting completely different thing. As x tends to plus infinity, g of x tends to minus infinity. But that is not possible if the parabola will come from this side. Okay, so this is not possible. It has to come from the below.
I think it is explained in lecture 410.
Okay, fine.
411.
No, I think fine.
So from the graph, you can see that in this interval 2, 8, in this interval 2, 8, the function is positive, and in this interval 12 comma 8, as you can see, the graph of this polynomial is basically above x-axis. That means the function is positive. Okay. So in both the region 2 comma 8 union 12 comma 8, the value of the polynomial is greater than equal to 0. Okay. And if you exclude 2, 8 and 12, 16, then you can remove that equality sign. You can write that P of x is strictly greater than 0. If we remove 2, 8, 12, 16 from this region, then I can say that in this open interval 2 comma 8 and the open interval 12 comma 16, the polynomial is strictly greater than 0. Okay, so I'm done with this one. Okay, is there any doubt?
No, sir.
Okay. Okay, so the next question is, yeah, so you have two functions. So both the function we have defined into different region. So this is f of x is basically it's a piecewise function. So for different region, the value of the function is different. Okay, for example, if x is in this interval minus infinity to minus 4, union minus 2 to 2, and union 4 to 8, the value of the function f of x is x power 4 minus 20x square plus 64. Okay, and if the value of if x is basically in between minus 4 to minus 2, union 2 comma 4, then the value of the function f of x is minus of x power 4 minus 20x square plus 64, and it is 1 if x is minus 4 or minus 2 or 2 or 4. Okay. And the second function is g of x, which is basically modulus of x. And if this is what the definition of f of x and g of x is, then you need to find out the value of the given expression, like whatever is written below. F of 4 times g of minus 4 plus f of 0 divided by g of minus 64 plus f of 3 minus g of 14.
Here we put the sir fx 0, sir.
Sorry?
Where we put cell fx 0.
Sorry? You need to compute the value of f at the point 0, that is f of 0, right?
Yes, sir. Yes, sir.
Yeah. So that certainly you have to find by looking at this function f.
Done, sir.
Yeah. Okay, so union means or intersection means and.
Sir, I have a doubt there. So we have to select the like based on the value, like we have to select which one we should go for, right? Now in f of 4, actually it from the first one, right? The last union it is given 4 to infinite, right? It is falling in that range, right? 4 is coming in that range.
4 is not coming because you can see there is an open interval there, right? Open interval means we are excluding that point.
Okay. So it will be the last one then for f of 4, the curly braces one, that value you have to take. So it is exact value, right?
Please, yeah. So please write your answer in over there. Like we'll explain. Like we'll see the solution. Okay, I guess we can. Yeah, can start. So the responses. Okay. Okay, so very wide variety of responses. Still, I guess majority of you said 0.
So I got 0. Is it right or wrong?
Yeah, basically 0 is the correct answer. So
okay.
But yeah, so I don't know. Like yeah, okay. So let try to solve this question. So yeah, so 0 is the correct answer. So okay, so let's go back to the question and so okay, so what we want to find? We want to find f of 4 into g of minus 4 plus f of 0 by g of minus 64 then I guess f of 3 minus f of g of 40. So okay, so first thing is so g of x is basically modulus of x, right? So this part is finding the value of g at a point is pretty easy. So g of minus 4 is 4, right? G of minus 4 is 4. So I know what is this. This is 4. So the next thing is what is f of 4. So if we go and see, as you can see, if you see the last expression in the definition of f of x, so it is mentioned that f of x is 1 if x is minus 4 or minus 2 or 2 or 4. Okay, if x is one of them, then the value of the function is 1. So that means in particular f of 4 is also 1, right? So this is 1. F of 4 is 1. So this is 4.
Sir, can you repeat, please?
So So what is if you see the last expression for f of x, what is written here? F of x is 1 if x belongs to this set, right? -4,
right,
-2, 2, 4. So now here x is what? 4, right?
Right.
So x belongs to this set, right?
Right.
That means f of x is 1. F of 4 is 1. Since 4 belongs to this set, that means value of the function at 4 is 1, right? That is that is what we are writing using the definition of it. Okay. So we are not doing anything new because it's already defined that f of 4 is 1. Okay. So so that means f of 4 is 1 and g of -4 is 4. So if we multiply, we will get 4. So the next thing is we need to compute f of 0. Okay, let's see what is f of 0. What is f of 0?
F of 0 is 64.
64, sir.
F of 0 is 64 because see, 50
64.
Yeah, so as you can see, 0 comes in this region, right? 0 comes in, if you see the first
-2 to 2
in the first expression, you have some region is given. So 0 comes in that region. 0 is basically in between -2 to 2. Okay, so it is given that in that region, whatever in the first expression, in that region, the value of the function is x power 4 -20x square plus 64, right? So f of 0. So that means f of 0, I just need to substitute the value 0 in the first expression. If you do it, then you will get 64, right? So because x power 4, which is 0 power 4 is 0, -20x square, which is 0, and you are left with 64. Okay, so the value of the function is at that point is 64. And g of -64, right?
This is also 64. This is the absolute value.
Yes. So then you are getting, so the final result is 1. This is 64 by 60. So the next thing is you need to find what is f of 3.
F of 3 is 35.
So yeah, so basically you have to go and check the region. So 3, as you can see, if you see the second expression.
It is second expression.
So 3 comes in between this interval 2, 4. Okay, so and by the definition of the function at this region, in whatever, if you see the region given in the second expression, so in that region the value of the function is basically minus of x to the power 4 -20x square plus 64. So I have to evaluate this one. So f of 3 is basically minus of 3 power 4 -20 into 3 square plus 64, right? This is what? Yeah.
Yes, sir.
So what is this value?
35.
35. Okay. So this is 35. So now next we need to find what is g of 40. And g of 40 is basically it's a modular function. This is 40. So what we will get? 35. This is 40. If we add this thing, get 40 minus 40. This is 0. So yeah. So if you do it, you'll get 0. Okay. So you just need to check. So when you are evaluating some function at some point, you need to check. So you have bunch of region over here. So you have to find out in which region that particular point belong. Okay. So according to that, you have to evaluate the value of the function.
Sir, in the third expression, there is a curly braces, like x is an element of.
That is a set. That is a set. Yeah.
Okay. So it is included. -4 is included.
Yeah. If something is there in the set, that means it is included, right? So curly bracket. See, there curly bracket means we're actually writing a set. Okay. So something is there inside the curly bracket. That means that is an element of that set, right?
Got it.
Okay, so let's
go
to
one doubt there. When it is in curly braces, that means it can have these values. It is not in range, right? It is either it can be -4, -2, 2 like that.
No,
it can have.
If x is one of them, then the value of the function is 1. That is what it's saying. It's basically how we are. F of x is 1. F of x is 1 if x is one of them. Right?
Yeah, I understand. So
got it, sir. Next question.
Yes.
If it's in the interval 2, 2 and 4 are not included, right?
If it is a open interval, yeah. So certainly it's a open interval, then certainly 2 and 4 are not included.
2 and 4 not included. Oh.
If so, instead of open interval, if I write in closed form, then you have to consider 2, 4 in that region. Okay, so let's go to the next question. So you have a bunch of functions. So question number 5, you have a bunch of functions, and you need to figure out which of the following function are even function. Again, certainly if you are getting more than one option correct, then write one of them. Okay.
What is even function? Actually, I am not going through some of the videos.
So even function is a function which satisfies this condition. Okay, f of so even function is a function which satisfies this condition, that is f of x is equal to f of minus x.
Okay, got it.
If a function satisfies this condition, then you say that function is even. And so you need to find out which of the following functions are even functions. See, you need to see, I can see some 20 responses. Okay, so you need to check all the options. Okay, so you check option 1 and you see, okay, option 1 is correct, then you simply click on option 1. So that is not fair. You should check all the options, then after that you should give your answer.
There is no option to take multi-correct.
You check and you submit your answer. In the end, we'll do it in the end.
Okay.
Done.
Yes, I'll discuss. So yeah, almost for 35 responses. Yeah, so the thing is, again, like I can see like most of you haven't tried option 3. Okay, so from your responses I can say, like, because most of you gave option 1 as your correct
Sir,
answer.
option 3 I can't do. I cannot evaluate with minus x.
So
sir, in option 3, if we put x is minus x, then that means f of x is equal to 1 plus 2 to the power x whole
we'll come
square.
to that. We'll come to that. We'll come to that.
Okay.
We'll check. We'll check each option individually. Don't worry. Okay. So basically, so 2 options are correct. Option 1 is correct, and as well as option 3 is also correct. Okay. So okay, let me do it one by one. So the first one is what is option 1? Option 1 is x to the power 4. Then minus 2x square plus 3, right? And to show that f of x is to know, okay, so to know whether f of x is a even function or not, I have to check whether f satisfy this condition, that is f of x is equals to f of minus x or not. So okay, so let me compute what is f of minus x. So f of minus x is what? So instead of x, I just have to replace minus x, right? If value of the function at x and value of the function at minus x, they are same for all x, then I can say that that is what we have written here mathematically. So if okay, so try to find out what is f of minus x. F of minus x is minus of power 4 into 2 into minus of x square plus, right? So minus of x power 4 is nothing but x power, right? Because 4 is even. Similarly, minus 2 and minus of x square is nothing but x square, because 2 is even, plus. And as you can see, this is precisely the definition of f of x. Okay. So f of x is f of minus x, right? So that means this is a even function, right? Is it clear why if this function is a even function?
Yeah, yes, yes.
Okay. So the next one is f of x is mod x minus 1, right? So the same thing I have to check whether this f is a even function or not. I have to check this equality, right? So let's start with f of minus x. If I take f of minus x, what I will get?
X plus
Minus x, right? So modulus of minus x is certainly same as modulus of x. Okay, so basically modulus of 2 is same as modulus of minus 2. Okay. So modulus of minus x is same as modulus of x, and I have 2 minus here, so I'm getting
plus x.
Plus x. So this is, so f of minus x is not same as f of x.
Sir, can you elaborate for third option?
I'll come to that. Okay, so that means this one is not even, right? So is it clear why this function is not even?
Yes, sir.
Okay.
If sir, if not even, that means it is odd.
No. If it is not even, that doesn't imply it's odd. Okay, there are few. So this function is neither even nor odd.
Okay. After that will come.
No, so see, you can say a function is even if it satisfies this condition. Okay.
Okay, sir.
You can say if function is odd if it satisfies this condition. Okay. So you can get some function which satisfy none of these two conditions. Okay, so this type of function, you say they are neither even nor odd.
So, sir, we are checking here if whether f, the value of x is in minus or in a plus. It will give the same polynomials.
Which one?
Why we check even, like it is even or not? There must be some reasons, sir. So that's why.
No, there are so many reasons. Like it's depend. Like in some sense, one of the reason is it's pretty easy for some with some kind of interval. It's pretty easy to integrate even and odd function. Okay, so that is one of the reasons, and there are many more reasons to study even function and odd.
Okay.
So and one more EA is basically you can write every function as sum of even and odd functions. Okay, so the next question is, next option is f of x is equal to 1 plus 2 power x whole square.
वहां पे आप पूछिए बिरला बॉयज हॉस्टल एक गली के अंदर है
2 power x, right? So I want to know whether this function is even or not. So let me start with f of minus x. What is f of minus x? It's basically 1 plus 2 power minus x whole square by 2 power minus 6, right? And if I expand it, what I can write 1 plus 1 by 2 power x whole square divided by 1 by 2 power x, right? No issue?
Yes, sir.
So then I can write this as 2 power x plus 1 divided by 2 power x whole square into 2 power x, right? 2 power x by 1, right? Which is basically 2 power x. So now what I can write this as 2 power x plus 1 whole square by 2 power x whole square into 2 power x. And I can cancel out this 2 power x and 2 power x whole square. I will get 2 power x, right? So then what I am getting? 2 power x plus 1 whole square divided by
Yes, sir. Now I get it.
2 power x. So this is basically 1 plus 2x whole square divided
So
by.
f is equal to f minus x.
So this is precisely f of x. Okay. So in the end, what we are getting, f of minus x equal to f of x. That means f is.
Right.
Sir, can we substitute values and solve? Sir?
How you are?
Sir, 1 and minus 1, sir.
Then you are just checking for a single value. You have to check for all real. Okay.
Okay, sir.
So when you are saying f of 1 equal to minus 1, then basically you are checking for a single value, that is x equal to 1, but it should satisfy all points in the domain. Okay, f of x equal to minus x for all x in the domain.
Okay.
Or like this, yeah. So then only you can say that, okay, this function is even function. But when you are checking for only one, then you are basically checking for a particular value of the, you are not checking all the values of the. Okay, so that's all. Like that is what I have planned.
Sir, I had a doubt, sir. Can I ask?
Yeah.
Thank you, sir.
Yeah, thanks.
So it was about turning points. So in tutorial 9, so in B4. Sir, in that, sir, turning point is there, but it is not crossing x-axis. Or we can say that it is not roots. Turning points are not touching x-axis. Then also, can we consider it for number of degrees? So that I
No, here this no. So here turning point is not crossing x-axis. Like you can have. So if you take a parabola.
Sir, means like space. Can you explain that question only, sir?
No,
So
if you
tutorial
take.
9.
Sir, I have a doubt that 2, 8, that graph which you have drawn.
4.
Yes, sir, this only. So number of turning points I understood, sir, but degree of polynomial.
No, that is incorrect. Number of turning points is not same as degree of polynomial. Number of turning points is not same as degree of the polynomial. Have you watched the lectures?
Yes, sir. All lectures completed, sir.
So how so from where you are saying that number of turning points is same as degree of the polynomial?
No, sir. I'm not telling that. I'm saying that, sir, here in given question, the turning points are not crossing x-axis, and we know that the highest degree of a polynomial relation between turning point and degree of polynomial is n minus 1.
No, no, that says something different. It says if the degree of polynomial is n, okay, it can have at most n minus 1 turning points.
Yes, sir.
But if degree is n, then you may not have any roots of that polynomial. All of the roots are complex. So if the degree of the polynomial is n, that doesn't imply that the polynomial will cut the x-axis n times.
Yes, sir, but like, sir, in option C and D, we calculated the possible degree of polynomial.
Suppose
and in
you have something like this.
Yes, sir.
So you have one. So maybe it's goes. Oh, so you have something like this, then something like this, then something like this, and here goes above. Precisely, you take this polynomial, right? X square plus 5. If you take this polynomial x square plus 5, this is a parabola. We draw the graph. What is the graph of this polynomial? Right, this. So you have one turning point, but it doesn't passes through x-axis, right?
Yes, sir. Means no real roots. So then, like here, how can we calculate the degree of polynomial by this graph?
No, if the
using turning points.
Yeah, so if the turning point, you suppose you have 3 turning points, okay, 1, 2, 3 turning points, okay, then you can say that, okay, so
Sir, means like the peak can also be the turning points now.
Which one?
When so peaks like in this graph, between two lines there is a peak, means top में जाके जब down हो रहा है वो भी तो एक turning point है ना?
No, you are saying this one. Huh? This
Yes,
one, right?
yes,
this is also a turning point. Yeah, correct.
So total 5 turning points
sorry.
in the
Yeah, I missed these points.
Yes.
Yeah, this is also a turning. Correct.
Yes, sir.
Yeah, so you have 5 turning points, right? 1, 2, 3, 4, 5. Then you can say, okay, then you can say the degree of the polynomial is maybe 6.
Sir, that you have grabbed this polynomials and it has no real roots, right, sir?
Yeah.
So how we, like, if the roots are in complex zone, so whether line intersect x-axis or not, if it is in complex?
No, it does not.
It's depend, like some of the roots can be complex, some of the roots can be real, so it's depend how you actually.
If it is complex, I'm saying, suppose let's say roots are in complex zone, right, sir?
What do you mean by roots are in complex zone? All the roots are in are purely complex number, you are saying?
Yes.
If all the roots are purely complex number, then certainly it won't touch x-axis.
Okay.
Sir, these are not touching x-axis, no, sir. Like the turning points.
Yes.
So they are not the zeros of the polynomial.
Correct.
They're just the like how do you define them?
No,
sir?
in general, turning points are not the zeros of the polynomial, right?
Yes, sir. They are used to.
Turning points are also not the zeros of the polynomial. Like if you know the zeros, actually it's easy for you to draw the graph. And by drawing the graph, you can compute the turning points. Okay. Certainly, turning points are not the zeros of the polynomial.
So they're just used for knowing the degree of the polynomial.
Yes, correct. Basically, a degree of the polynomial and as well as to draw the graph also. And see.
So for this graph, can we answer all the questions which are given in tutorial, like find the number of turning points, find the number of fruits? For the graph you have drawn in the page. All the questions can we answer, sir?
Yes,
So it will be clear.
yes. See, you cannot tell the precise degree. You can tell the minimum degree. Okay.
Yes, sir.
Yeah. So.
Sir, I have a doubt.
So here you can easily say that the number of turning points is 1, 2, 3, 4, 5. Right?
5. Yes, sir.
And you can say that the minimum degree is 6.
Sir.
Yeah. Yes,
sir. Let's say there is
just a minute. So okay. So any other question you want to ask?
Yes, sir. So like sir, here the question is miss in tutorial line. There's also a question number of roots. We have to find number of roots.
So here the number of roots for this graph, okay,
is 0.
So it's 0, like, because certainly it's not passing through x-axis, so that means the number of roots is 0.
Yes, sir. Okay. And so the next question is minimum possible degree of the polynomials based on the roots. Then here it will be
based on the roots. Yeah, based on the roots, then it is 0. Yeah.
0, okay. Sir.
Basically 0. Yeah. So if you are going to say on the base of the root, based on the roots, then it's 0. Okay, because the polynomial don't have real roots. Okay, since it don't have real roots, that's why the degree is 0. Okay, but if you use the concept of turning points, then you will get 6 minimum.
Okay. And so last thing, so like if if there was one intersection or 2 intersections, so in this graph only, it has either 1 or 2 roots, so then our degree of polynomial by roots will be 2, na sir?
Yes, 2. Yeah. So suppose if the graph is something like this, suppose something like this. Okay.
Yes, sir.
Then you have 2 roots, right? Then the degree is 2.
And so the last question in tutorial is we first find the minimum possible degree based on roots, minimum possible degree based on turning points. Then it is asking minimum degree of the polynomial, in which in video they have taken the greatest value among both the minimum possible degrees. So why they have taken the maximum value among both?
Because this tells you using the turning point, this tells you the degree of the polynomial, okay, is always greater than or equal to 6, right?
Yes, sir.
And using the root, it tells you the degree of the polynomial is always greater than or equal to 2. So what is the common part in between these two? So one is saying it's 6. One is saying it can be 6, 7, 8, 9, dot. Okay, and another one is saying 2, 6, 2, 3, 4, 5, 6, 7, 8, dot. Okay, so what is the common region in between two things? 6, right? So then you have to take that one, right?
Okay, so means like 6 can be the least value which will satisfy both.
Correct. Yeah, 6 is basically the least thing which will satisfy the both.
Sir, I have a doubt. In question 3, like which you have done today, like the graph 2.
And so last thing, sorry,
okay,
sir,
let him complete. Yeah.
And so last thing, like after we calculated the minimum degree of the polynomial, So they have asked highest degree term, coefficient of highest degree term.
Coefficient of highest degree term. No, this is, I guess, the end behavior of the coefficient of the highest degree term. You should, yeah. So yeah, then you can say like
it's positive.
So just the sign of the highest degree. That's
Uh,
positive or negative.
Yes,
no,
so
this
miss
is,
sign in answer it was positive.
Okay, so the thing is, it's a odd degree polynomial because you have number of turning points. Okay, number of turning points is 7. That means it's a even degree polynomial. Yeah, so it has to be positive, right?
Positive. Because
Because
P of X is coming from infinity and going to infinity.
So okay, so the thing is, yeah, so P of X is what? P of X is something a times x n, right? And n is even, right? And as you can see, if you see the graph, as x tends to infinity, the value of the function actually goes towards infinity,
Yes.
right? So if you consider a to be negative,
Yes,
then
sir.
this is not possible. So a has to be positive, right?
Sir, I have a doubt in
Yeah.
third
Yes, sir.
question.
So I guess you have asked all of your doubts, right?
Yes, sir. Yes, sir.
Okay.
Thank you,
Okay.
sir.
Yeah. Thanks. Yeah.
I have a doubt in third question, sir, which you have done today. That graph one. Like
Question
graph
number.
one, yes, 2, 8, 12. Yeah, the fourth statement.
Okay. The fourth one. Yeah.
Yes. Can you once show me the graph, sir? Yeah.
Okay. I guess this is the. Yeah. So
Yeah.
this
So
is the graph.
here, sir, near 2 and 8, why doesn't it go from down, sir? Like from 8, like how it went from 12 to 8 downwards. Why isn't it going from 8 to 2 downwards?
So you are saying why? So why it's not coming like this, right?
Yes, sir. Okay,
So
okay. Because 8 is multiplicity is 1, so it should cross over the x.
1 is odd. That's why it should cross the x-axis, right? It should go like this. Again, the multiplicity of 2 is 1. Again, it
So
should
it
cross.
will cross. Okay, sir. And in tutorial 13, like once can you show the graphs? Like,
Tutorial 13.
yes, sir. Here near S and T, sir, they have taken it as 3, sir. The degree should be minimum of 3. Like in a question, minimum sum of multiplicities they have asked, sir. So from S to T, the sir calculated it as 3, sir, there. So why can't it be 1, sir? Because it is crossing over x-axis. We can take minimum, so we can take the degree as 1 also, sir. Why did he take it as 3?
The more you get the power, the more flattened the curves get.
Okay, in S and T, right?
Yes, sir. Yes.
So the problem is, okay, so if you see actually if the multiplicity is 1, okay, am I audible?
Yes, sir.
Yes,
sir.
sir. Yes,
You are
sir.
audible.
Yes, sir.
The
Yes.
multiplicity is 1, the graph will cross directly.
Yeah.
If multiplicity is 3, then it will flatten.
Yeah, it will actually basically whatever.
The more the power gets, the more the flatten the curve get. Whether it is even or odd, doesn't matter.
So if you draw the graph of this line x, right? So it will cross this. So this is flat, right? So this is a flat line.
Yes, sir,
This
yes.
is the line of, this is basically the line y equal to x, right? But if you draw x cube, okay, so it will go something like this, right? So this is slightly more. If you see basically the curvature is more. So
Yes,
here, so you see the bend, it's slightly more. If you compare the bendness of both the curves, so it is slightly more bend. So
how to identify if it is 3 or 5, sir? It will be
that is difficult. That is actually you have to check with degree. Okay, whether if you are taking 5, whether it crosses the degree of the polynomial or certainly you can say that by looking at the picture. You can say that okay, if you have some big picture, you can say that certainly that multiplicity is not 1, but it's difficult for you to figure out whether it's 3 or it's 5 or it's 7.
Yes.
Okay.
And one more doubt, sir. Last one. 4.2 practice assignment, question number 6. Practice assignment, sir.
Have you checked the solution?
Yes, sir. Yes.
Okay.
I didn't understand.
Question number 6, right?
Yes, sir. 6. So how did they take C1, sir? I didn't understand this thing. Like the union part.
So
I've calculated M and N, but C I didn't get it. How did it?
C basically it's M intersection N, right?
Yes, sir. Intersection.
So what is
Only the common parts we should take now, sir.
Yes.
So in N we don't have -8 and -8 and 8, no, sir. Only in M we have. In M we have -infinity, -4, 4 infinity. In N we have -infinity, -8, union 8, infinity. So if we are combining, when we are taking intersection, only -infinity, -4, 4 and infinity comes, no, sir, because the N part isn't.
Okay, just a minute. Can you repeat what is M?
M is -infinity, -4.
-4.
Union 4, infinity.
4, infinity.
Yeah, and N is -infinity, -8.
-8.
Union 8, infinity. So C is the intersection of M and N. We should find C.
What is C?
Yes.
We just So what is this region? -infinity to -4. This is -4, right?
Yes, sir.
So this is one region, and another region is what? -infinity to -8. Oh, -8. What is the common region?
-4, sir. -4 to -infinity.
No, in one part you have from one part you have up to here, and another part you have up to here. What is the common part?
Okay, -8 to infinity.
This part is common to both the sets. Right?
Okay.
So that means this is actually, if you take this part, then you will basically get -infinity to -8, and here you will get 8 to infinity.
Yes, sir. Got it. Thank you, sir.
Yeah, thanks.
Sir, I have a doubt regarding SSC. Some word errors. So I don't understand it. Please.
Have you watched any live session of week 2?
Yes, sir. I've seen everyone. I didn't understand it. After that, I did one graded assignment also. In that first one which one was easy, so I took it off and it was correct. But the second question was quite a bit lengthy one, so I didn't understand it.
No,
I also saw the solution.
No, you are saying two different things. You are facing solve problem, or you are facing to understand the concept.
And to understand the concept, sir.
Concept. Have you watched the lecture?
Yes, sir.
Okay. So which part, like, so basically you want me, no. So the thing is, no, my main concern is if you know how to solve the question, then
So actually, I just got a little of it.
Mhm.
In that, we have to do y square minus that
Mhm.
equation, and we have to find the appropriate and which one is having the less
yeah.
minimum sum. It is the correct one.
Hmm.
So I used it. So the question was, the first question which I solved was just a normal linear equation. So it was a very easy one. So I scored it. But second was in terms of very great numbers. So
Basically, you are
unable to solve.
asking question from graded assignment week 4, right?
I'm asking, but sir, it was
No,
more
that
of
is what you are asking, because see, there is no quadratic thing in week 2, right?
Yes, sir. There is no
Yeah,
quadratic thing. I understand that.
yeah, that certainly I'm not going to discuss. If you have doubt in quadratic, then you do it on your own. Because the same procedure, just in the end you will get some parabola, and finally you have to find out the maximum value of that parabola. That's all. Okay, there is no point of discussing that.
So in that, we have to do the same thing. We have to put the y square value which is in the table, and we have to put the x value with the equation.
Correct.
So which one comes the less minimum sum is the right one.
So basically, in the end, so now you have degree 2, right? So in the end, you will get something like this: ax square plus bx plus c, right? And you know how to compute the minimum value. If a is negative, you know how to compute the minimum.
No, sir, I'm not asking this. It was not quadratic. Just as it was in the lecture, it was given y is equal to, we have to suppose y equals to mx plus c is our equation. So sum squared error will be y square minus whole mx plus c whole square. So in that, we have to do y, we have to put the value of y from the table, and then we have to put the appropriate value of mx plus c.
Yeah, correct. Suppose something is given like this. Suppose you have y equal to some. Okay. And you have let's say xi and yi,
Okay.
and for each xi yi you have to compute yi minus f of xi square, right?
Yes, sir.
So if y is, let's say, 2, xi is 3, what you have to do? You have to compute 2 minus f of 3
yes,
whole square, right?
Okay.
And
okay.
Similarly,
and after that you have also do the sum.
For suppose you have another thing is that let's say 4 and 5. So for even for this pair you have to compute yi.
Okay. Yes, sir.
Then you have to compute the sum.
Yes, sir. It's the same thing I was saying. And also, sir, in that lecture, it was given that when the x value was increasing, yi value was decreasing. But in that lecture also, the teacher said we should not be available with that such type of tables every time, in which x value is increasing and y is decreasing. There will be some irregularities. So when irregularities come, we do the same thing just as we are doing it right now.
No, sorry, can you repeat? Like I didn't understand what you want to say.
In that, in the lecture, the question which was taken, for example, the table was like xi was increasing and yi was decreasing. We were able to see, we were able to see the in which value was taken, but said ki irregularities will be there. They will not always like xi will be increasing and yi will be decreasing.
Yeah, that is
we will
depend
do
on
the same thing.
You should do the same thing. See, it's depend on the function. Okay, if you are taking some nice function, then probably if you increase the value of x, then the value of y will also increase.
Means the sum squared error is nothing but just this yi minus fxi whole square, and sum of that, and which is the minimum one, we will take it.
Yes.
Okay.
Yes.
Thank you.
Yeah.
Thank you.
Hello, sir.
Yes.
Sir, I have a fundamental conceptual doubt you can explain in like very short time. I have gone through your last open session, which is available on YouTube, but I didn't get this. Sir, I want to know the end behavior. Like I have solved many questions, but still I have in dilemma like how to do that. For example, if we have provided any polynomial, so what is the end behavior like? I know if a is greater than 0, that is the stretch factor is greater than 0. For even and odd, what are the things that we have to do? What is infinity? What is minus infinity? And for a is negative, what is infinity and what is minus infinity? I have noted down as well, and I understand why it is infinity and why it is minus infinity. But my question to you is, how can we draw rough graph of the given polynomial? For example, my main query is where the graph should be starting from, whether either below the x-axis, above the x-axis, or it should be crossing y-axis.
That is why we compute the end behavior, right? So so if we compute the so my first question is, you know how to compute the end behavior, right?
Yeah, I know roughly, sir. I know, but if you give me any polynomial, I can't make a graph. Like I can distinguish graph.
Suppose I am taking this polynomial, let's say minus x time x minus 2, x minus 3, x minus 4. Okay. So first tell me what is the end behavior of this polynomial, like as x tends to infinity, where this polynomial.
So as I can see, sir, the a is negative for this polynomial. So when a is negative for this polynomial, and we can also see the multiplicity is odd. It is
so degree is 3, right?
Yeah.
So what is basically the leading
when x tends to infinity, sir, the function will tend to.
Okay, so the thing is, you should, I guess you should watch the session again, like
because in the
no. The thing is, okay, there is one process. So basically, I have followed that process for 1 hour. Okay, so first what I did, I have computed the leading term, right? So if you compute the leading term, this is basically minus x cube, right?
Yeah.
And you will get something else, right? Which we don't care, right? So as x tends to infinity, okay, so you can say that x cube tends to infinity, right?
Infinity, right?
And minus x cube tends to minus infinity.
Minus infinity. Yeah.
So basically the polynomial, that means the polynomial tends to minus infinity, right?
Yeah.
So that means
सर समझ में आ गया. इसके बाद वो जो स्लोप बनता है उस पे इशू है कि where should it be started?
So then it should come from below, right? So now you try to mark the roots on x-axis. You have 3 roots, right?
Yeah. I have 3 roots. 2, 3, and 4.
3, 4. So yeah. So the first thing is your graph of the polynomial should cut this one, right? The last root, that is 4. But it can come from this direction and can cut it, and also it can come from the below and can cut it, right? You have 2 possibilities.
Yeah, we have 2 possibilities.
But by the end behavior, what you are getting from this thing, you are getting as x tends to infinity, the value of the polynomial goes towards minus infinity, right? This is what we have computed, right? As x tends to infinity, the value of the polynomial goes to minus infinity, right? But if I will come from this direction, if I will come from the above one, what does it mean? If I'm coming from the above one, what does it mean?
It means plus infinity, if I'm not wrong.
If I'm going towards when I'm taking x towards plus infinity, then the polynomial is going towards also plus infinity, right?
Right.
But in the beginning we are getting something different, right? So that means it cannot come from this direction, right?
Okay.
So it has to come from the below part. So it has to come from this side, because if it will come from this side, then basically this contradict whatever we computed in the beginning. As x tends to infinity, the polynomial function goes towards minus infinity. But if you are coming from this side, basically what you are getting, as x tends to plus infinity, the polynomial function is basically going towards plus infinity, which is not possible, because just now we have computed the polynomial function goes toward minus infinity. So it has to come from this side. Right. We don't have any
so
other
starting point will be that.
Yeah.
And then graph will be like zigzag. And
then no, not zigzag. It has to.
It has to be deal with multiplicity.
Correct. Since you have only one multiplicity, will cross, then
it will
come,
cross, and it
then
will
go.
That's what zigzag I meant for.
So thing is, okay, once you know the behavior in one side, okay, then you don't have to the check end behavior of the other side. Okay, that you can do by checking the multiplicity over here.
So some graphs start from right side and some graphs starts from left side.
So see, so here what I have computed the behavior in the right hand side, right? I have computed the behavior of the polynomial on the right hand side. I have computed as x tends to infinity, the polynomial is going towards minus infinity. So I am checking on the right hand side. So that's why I have started with right hand side. Suppose if I'm not going to compute the behavior of the polynomial on the right hand side. I'm simply compute the behavior of the polynomial on the left hand side. Using that also I can compute the graph. Suppose let me see what is the behavior of the polynomial when x is going towards minus infinity. If x tends to minus infinity, then xq also tends to minus infinity, right?
Right.
That means minus xq tends to plus infinity, right?
Plus infinity.
So since now what I have done, I have computed the behavior of polynomial in this direction, right?
Okay.
So now I will try to draw the graph in this direction, right? This is, let's say, this is 2,
3 and 4.
Since as x tends to minus infinity, the value of the polynomial is plus infinity. That means it cannot come from this direction, right? It cannot come from this direction, right? Because if it is coming from this direction, that means as x tends to minus infinity, the value of the polynomial is going towards minus infinity, which is not the case. Okay, so it has to come from this direction. Okay. Once I fix this, then automatically I don't care. I don't have to compute the value of the polynomial in this direction. That I can conclude by just checking the multiplicity of 4. Okay. I will come here, it will cut, then it will go, then it will cut, because
okay, so in short we have to calculate only one side and then we can easily get an idea of rough sketch.
Correct.
Okay, sir, that was my main concern. Thank you, sir.
Okay, thanks. Okay, so I'll stop the session. Okay, thank you.
Thank you, sir.
Yeah, thanks.
Thank you, sir.
Yes, thank you.
Sir,
Yes, sir.
Yeah.
so for the qualifier, do we have to go through all the tutorials?
I don't know, like generally you should, but if you have understood the concept, like the concept that is given in the video lecture, then probably.
Okay, sir. So also, will we be allowed to use any online tool like Desmos?
Sorry?
Sir, will we be allowed to use any online computing tool?
No, you can't use Desmos. Yeah. And also, whatever question will give you in exam, you can do it without using Desmos.
Okay, sir. Thank you, sir.
Yes, thanks.
Sir?
Yes.
So till polynomial in exam, till polynomial will be coming, right?
Week 4, yeah. Week 4.
Yeah.
Yes.
Okay, sir.
Thank you.
Thank you, sir. Good night.
Good.
Sir, also, will we have only 10 questions from maths?
10 question, I don't think so. I have to check the question paper, then only I can confirm.
Last time it was between 10 to 15, if I'm not wrong.
Then so certainly it's hardly
it can go maximum up to 16 if and it can go minimum 12.
Yeah, probably.
I'm not sure, but the rough idea would be is that between 12 to 16 or 12 to 17.
Not 16. Okay, just let me check the question paper, then only I can tell you. Just wait a minute. It's 10 actually. Number of question is 10. Okay.
Thank you, sir.
Yeah, thanks.
Hello. Hello.
Yes.
So actually, let her ask.
Sir, what is the week-wise weightage for math?
That will let you know. Okay. Not now, we'll let you know.
Okay.
So I have a query in week 1, question in week 1, sir.
You please ask in the revision session. Okay.
Okay,
Yes.
tomorrow, sir.
Yes. Yeah.
Sir, attempting 3 graded assignment is enough, na? 4th one is compulsory or not?
I don't know, like what is the criteria?
If you have scored well in 3, you could no need.
Sir, it will be only calculated 3 out of 4.
It would
Okay,
be
best.
taking
Okay,
best
so
3 or 4 out of 4.
yes, if your mark in all these 3 assignment are good, then probably it's fine.
Okay, thank you, sir.
Okay, thanks. Okay, okay, so I'll stop the session. Okay,
Yes,
thank you all.
Thank you, sir. Good night, sir.
Good night.
Thank you, sir.